Welcome everyone. We are about to begin our webinar for our new CAM credentials. So first, before we do that, Montez, are you there and are you ready to begin?
Yes, I am here. I'm ready to get started. Hello, everyone.
Okay, if you want to go to the next slide. So this is just for everybody to understand how the basics of the webinar will operate. Because it's a webinar, only the hosts and panelists can speak. So if you have any questions or if you're having any technical difficulties, or anything like that, please use the chat, which is circled in green. And if you have questions, we'll be answering all the questions at the end, but you can put them in the Q&A circled with the yellow at any time throughout the webinar. And at the end of the webinar, we'll have a Q&A session and go through those and answer as many as we can. Okay, next slide. So joining me on the webinar today, first, I'm Rebecca Hutton, the Deputy Executive Director of NIMS. I'll be going through the first bit of the presentation, and I'm joined by Montez King, our Executive Director, Alex Starner, our Technical Director, Dina Igo and Kendra Hurt will be on helping answer questions and monitor the chat. So that is our team. For the goals for our webinar, we're going to just do a brief review of the new CAM credentials, how they came about. We're going to explain the features and use of our new performance measures. We're going to provide some highlights on training resources that are available to support the CAM credentials. And then, like I said, we'll have a Q&A at the end where you can ask any questions about the content of the webinar. Next slide. So why do we need CAM credentials? First of all, they're going to allow our education and industry partners to customize your credentialing experience. These are kind of a new format of credential for NIMS, which we'll go into in more detail throughout the presentation. But essentially, it allows you to use your own projects to validate performance. We anticipate that manufacturing companies will look forward to having these credentials, because having CAM programmers and designers that are properly trained is something that helps, reduce material waste and errors in machining and increases the quality of the parts. The goal, I want to be very clear, and we'll repeat this throughout the presentation, but the goal of the CAM credential is to validate skills for programming, not for machine operations. So this is specifically a CAM programming validation. Next slide. So how the CAM credentials came about, I believe it was in about 2015. We partnered with Autodesk, who provided funding and subject matter experts, as well as helped us recruit additional subject matter experts. And they worked with us over about a 2.5-year period to complete the two credentials that we have. It's CAM Milling and CAM Turning Level 1. We launched those credentials last year. And then at the beginning of this year, we finalized, we had completed the pilot in 2019. So we finalized all of the resources and practice tests and things like that early this year. And so that's the purpose of this webinar, is to review the credentials themselves and then also show you what resources are available. We worked with several, like I said, Autodesk was our primary partner in this. Mastercam also assisted in helping us with the study guide and practice test. And then we couldn't have completed it without Jimmy Wakeford from Barefoot CNC. He was the head of the technical work group that really drove the process to completion and made sure that we had good, solid credentials kept the working group on track to get these credentials released last year. So we appreciate all of our partners, and we look forward to rolling this out, and we hope that you'll find the webinar useful and helpful and give you good information that you need to roll these credentials out in your training programs. The next slide. So we're going to focus here at the beginning on kind of why and how new NIMS credentials are customizable. I mentioned that a minute ago, but basically we have kind of reformed our entire system using smart standards and smart performance measures, and the CAM credentials are going to be the first official NIMS credentials rolled out in this new model. So we're going to go over kind of what we mean by smart standards and smart performance measures. For that, I'm going to hand it over to Montez.
Hello, everyone. Thank you again for joining our webinar. We hope that this will be useful for you. Obviously we are online. There could be some latency in this next slide. It's an auto play slide, so it's about, I don't know, maybe less than a minute long. The graphics probably will not come through as smoothly as it would if we were face to face. So just bear with it if it's a little choppy. This is a high-level concept of how smart standards work, and then we'll do a deeper dive to get a better understanding. So you're just going to see more of a graphical explanation of smart standards and how they actually work. I'll probably talk through it, but I'm not sure about the latency. As a matter of fact, I will not talk through it. I'll just throw the slides and then I'll speak afterwards because I'm not sure where I am with the slides on your end. Well, I actually will talk through. So the understanding of the complexity gap, you're seeing duties continue to stack within an occupation. You also notice that they expanded on your screen because not only are we adding more duties or responsibilities, the duties and responsibilities themselves are getting more complex. So the way organizations are mitigating through this is defining industry recognized roles, which is a smaller scope of the occupation. And so bringing over duties allows you to customize roles. And you can fully customize by going outside of the normalcy of, what's expected within or generally accepted across an industry. And of course, you can just slide them all out and you can start all over. So regardless of how your roles are standardized, the key here is regardless of what roles you use and however you customize, you're always standardized because each standard is at the duty level. Now we'll get into that a little bit later, but this is just a concept of how it works. Overall, instead of focusing on a larger occupation and expecting an individual to attain all of the skills related to every duty within an occupation, this allows you to pick and choose, and for a company or an organization to define which duties are relevant to them and build their roles for their organizations. But regardless of how they choose, they're all standardized because the standard is not at the occupation, it's at the actual duty. So we'll get into that a little later. Okay, so let's look at our new credentialing process. So most of you are familiar with our credentialing process, where it's performance plus theory equals credentials. So we're competency-based credentials. So individuals have to demonstrate their ability to perform as well as the cognitive through theory to equal the credential. However, we've enhanced the performance into what we call performance measures. So look at performance measures as an all-in-one package. It's all contained, and what you're seeing are all of the components that are associated with a performance measure. So we've labeled them as delivery, project, reproduction, data, and reports. Now, what sits outside of the performance measure is a performance agreement. So we'll get into the meaning of each component, but for now, look at it, it's still performance plus theory equals credential. However, performance is enhanced into what we call a performance measure. Okay, so let's look into the framework of a performance measure. So a performance agreement defines the scope of the performance measure. It is a one-page agreement between stakeholders. Now, the stakeholders are considered the trainee, the trainer, and the organization representing both. So it defines the scope of the performance. Now, when we say trainee, all stakeholders, trainee, trainer, and organization, it's because in this system, all are considered performers. So you're not just looking at the trainee as the performer, but even the trainers and the organization are recognized as the performers. Okay, delivery. So delivery are resources required for an organization to administer the project. So any resource that's required for anyone, for it to be managed or administered, those are labeled as delivery. Anything labeled as a project are resources provided to the trainee to satisfy the project. Now we'll get into this a little deeper as we go into the CAM credential. But if it's something that the trainee needs to perform the duties, that's labeled as project. Reproduction. Reproduction are resources for a project organizer to manufacture unique components that are required for project delivery, but are not readily available for purchase. So if there's some type of project that you are designing where it requires some type of fixture, then you would require, you need to have the artifacts to build that fixture. So it's not necessarily, it's something that you need, but you can't go down to the Manhattan Supply Company and buy it. You have to build it. So you need all the artifacts for that. Now data, these are the observed features of the performance measure. What is it that you're looking for? What are you measuring about the performance? What's important to you? And then finally, we have reports, which is a dashboard of graphs that benchmark the performance of all stakeholders in the community. So this gives you useful information to understand what's happening with the performances for your performance measure. So where are you seeing successes and where are you seeing areas for needed improvement? And remember, it's for all stakeholder performers. So it's not just looking at needed areas of improvements for the trainee, but it's also looking for the trainer. And obviously the organization is a part of that and represents both. Okay, so let's do a CAM PM overview. So performance measure, you'll often hear me say PM. Some people say, well, that stands for preventive maintenance. And we say, yes, it means the same thing. It's synonymous to us. Performance measures are actually preventive maintenance as well. So you'll hear that term PM, that just stands for a performance measure. So we'll do a CAM PM overview. Okay, so here are the resources associated with the CAM performance measure. As you go through, you'll see the first column, those are your performance measure components. Remember, we talked about performance agreement, delivery, project, data, reports, reproduction. So those are just labeling that's telling you how the documents are labeled. So for performance agreement, that's a component and the document will be named performance agreement. And its intended audience is trainee, trainer, and organization. So all of you are performers. So this is an agreement between everyone. For delivery, we have instructions for the trainer. We have evaluation checklists for the trainer or the evaluator. We have infrastructure requirements for the organization. We have projects or a project resource called instructions for the trainee. And we have project resource called models and prints. That's also for the trainee. We have project resource list, which is for the trainee provided by the organization, which gives you a list of available equipment to satisfy the PM. It's your infrastructure. And then obviously you have the data and reports, which is a digital tool that NIMS has developed. We've developed a pseudo tool that you can use. We are in the process of building a more robust system, but this is a very useful tool as well that everyone has access to measure or to observe the features and obviously report useful information from that. And reproduction is not applicable in this circumstance. There's nothing that we have that has to be manufactured, at least from the PM that we've developed. If you develop your own, it may be applicable. Okay, so let's look at the CAM performance measure. Final validation method is part verification. So if we are measuring the programmer through verifying the part. We're not necessarily looking at the program itself, the virtual environment. We're looking at the end result, similar to what happens in industry. There's also in-process validation through observation. So these are observations that take place during the performance, where part verification is after performance. So you may look at the part and measure that to see what the results are, but there may be features that you need to observe during the performance, and it cannot wait until after. And we can get into more detail into what features we have, the features that we observe in our PM. Someone other than the candidate must run the program in a physical machine. So remember, this is not a machine operator or setup person credential. It is a program credential. So we're measuring an individual's ability to write a program so someone else can run it. So someone else must run the program in a physical machine. They must use the deliverables from the candidate. So any setup sheets, instructions, tool lists all come from the candidate. The part must be produced. Part must be produced 100% to specifications. The machine operator can only perform minor adjustments to speeds, feeds, and offsets. There are no geometry changes allowed. All right, so no geometry or work holding changes or markups on documentation are allowed by the operator to bring the part into specification. If there is something wrong, the operator rejects the program and returns it to the trainee with a specific explanation about what is wrong. Okay, so before we get into the actual project itself, we're going to demo the CAM project. Let's do a deeper dive with SMART standards. We're going to dive a little deeper into that to show you what it looks like. Okay, so let's look at the framework. Duties are one-pagers. So you can see the duty structure to your right. Every duty is just one page. It's never bigger than that. It's a very simple way of interpreting standards, far unlike what we've had. This is a much easier way. And so each duty or standard includes the responsibility in 100 words or less. It's simply describing the responsibility within the duty. The resources available to perform the duty. And performance is broken down into practical and critical thinking. So when we say practical, we're identifying learned behavior. When we say critical thinking, we're saying judgment or decisions. When it comes to compliance, we're saying level required to satisfy the duty. And evaluation is the method to validate the duty. So duties are, again, individual standards. That means duties are revised independently. You're not, if you're making an update to standards, you're making it at the duty level and not at the full occupation level. It's not a mass overhaul. You can update one duty independently from others. Duties state minimum performance, not specifications. It's not going to say must be able to drill holes within plus or minus. It's telling you what you must be able to perform, but it does not get into specifications. Duties are used to design performance measures. There's that acronym, PMS. So we use the duties to design performance measures. Duties are organized into industry roles. In this example, as a CAM program. So that's an industry role. We all work, you may work identify yourself as a machinist, but in this case, your role is a CAM program. Credentials are aligned to industry roles. Roles are not identified by complexity levels. In other words, there isn't a CAM level 1 or a CAM level programmer level 2. Complexity is expressed through the PMs. So if in your facility, as long as you meet the minimum requirements, you can increase the complexity to what works for you because complexity is relevant. Knowledge requirements are listed by role. So that's another document. Okay, so what are some benefits to SMART standards? Let's look at it. Easy to interpret, very easy because they're one-pagers. Allows for a shift towards true competency-based training. You'll have to join one of our other workshops to show you how to actually structure true competency-based training. However, SMART standards allows for that shift more seamlessly. Easy customization while maintaining standardization. So it allows you to kind of like build a bear. Many of you have kids and you take them to the Build-A-Bear store and you can say, okay, I'm gonna get this base bear and then I can add all of these little items and I build my bear. Where you can build your roles the same way using SMART standards to build the role that's right for you. But regardless of how you build, you're standardized. Ideal for adding or revising duties to keep pace with emerging technologies. So we can easily update or add duties, or we can update existing duties without having to do a mass overhaul of the entire collection of standards. Organizes training into short-term tracks that align to the objectives of stackable credentials. So stackable credentials are themed to have a building block to move you through, and SMART standards align to that actual theme. Okay, so now we can get into the standards. I'm going to tab over and I think, can anyone, a panelist, tell me if you had a successful transfer of screens before I get started?
No, you need to share you change what you're sharing.
Okay, so it did not. How about now?
You're good.
All right, thank you. Okay, so we're first starting. This is just something that we put together. It's just giving you a description of the duties. This isn't the actual standards, but we're just giving you a description. So here's a role description. So a CAM milling programmer, this role requires an individual to independently process, plan, and program parts requiring 3 or more axis programming and create documents required for a machine operator to set up and run production. So here are a list of the duties. So the first duty area is called CAM. There's only 2. This first duty area is called CAM. And the duties under duty area CAM included process planning, modeling, toolpath creation, program verification, and documentation. And then the second duty area is programming. This is coding. So this is being able to alter G codes as needed, not writing full G code programs, but just executing some type of programming and at that level. Okay, so understanding SMART standards is just what we went through that through the slides. Okay, so I'll go through the standards. So here is the first duty under CAM. So you can see the responsibilities. This is for was CAM milling programmers the role. Duty area 1 is CAM. Duty 1.01 is process planning. The responsibility is formulate strategies to machine parts. Here are the resources. You have a list of available CNC machines, tooling, work devices, and drawings. And the performance, again, is broken down into practical and critical thinking. So your practical skill here is documenting process plans in digital or hard form. Your critical thinking is process planning parts requiring, requiring multiple operations, so that's a reclamping. B, with several features requiring 2.5 axis milling applications. And C, with several features requiring simultaneous 2-axis milling applications. You must also have critical thinking in selecting A, machine tools, B, work holding devices and accessories, C, cutting tools and holders. And you need critical thinking skills in determining A, extension out of holders and length of cuts, and B, speeds and feeds. The compliance is full, meaning that you must satisfy all conditions of this duty within your performance measure. And your evaluation method is part verification and observation. Okay, so that's just the first. I won't read them all through, but I wanted you to get an understanding of how they're all one-pagers, and that's process planning. Modeling is very simple. You access the software, solid models, and drawings. You must create solid models. You're modifying existing solid models, and you're mating or joining solid models. Critical thinking is verifying models against your drawings, as full compliance, etc. And then you have toolpath generation. I will read this one as well, and then we'll push through. You're creating toolpaths for parts based on process plans. So that plan that you created here, you have to generate toolpath for a part for the process plan for the parts that you planned out. And so you're creating toolpaths and you're rendering parts with work holding devices. So you're showing the part and how you're holding it. You're rendering B, secondary operations, which means reclamping with rendered part from prior operations, and your post-processing. Your critical thinking is avoiding collisions and gouging, and 2, comparing rendered parts against models, and again, full compliance and evaluation. And then you have your G-code program that are verified in a virtual environment. So you're simulating virtual environments and you're analyzing rendered parts for gouges, comparing rendered parts against solid models, and determining potential machine collisions. Again, full compliance, part verification, observation, and finally, you're documenting. You're creating all the technical documents in digital or hard form. So you're creating technical documents required to communicate instructions required for machine operators to execute programs. So these are all the duties that you must satisfy to, well, we have a PM that's the expression of these duties. However, you can, as we go through, you can design your own as long as it meets the minimum requirements of these duties. Sorry, there's one more, is coding. So write G-code programs to machine parts or qualify work holding device accessories for machine setups. So if there's some type of execution that you need at the G-code level, you should be able to make basic programs. So manually writing G-code programs for 2.5 axis machining applications, and editing existing G-code programs. And your critical thinking is debugging syntax and program errors. Compliance here is partial because this is something that may come up that you may need, but your PM does not have to include it, but you should know how to do it in case it's needed because you never know what happens on the floor. So it's a partial compliance. Okay, so I'm going to switch. Okay, can I get a cue? Are you viewing the right screen?
Yep.
Okay. So we looked at the standards. Now we will do a CAM PM review. Okay. So let's look at the activities. What is it that, this is a high level, what are you actually going to do? You're going to compare models to drawings. You have to look at the models, look at the drawings and compare them. You have to modify models to correct any discrepancies between the models and the drawing where the drawing has full authority. You have to create opposite hand models. So there's a left hand or a right hand and you have to make the opposite. You have to program parts. So there's more than one part that you're going to program. And you have to create all the technical documents to pass on to a machine operator. Okay, so let's look at some drawings. Okay. All right. So let's look at an edge clamp. This is one part that you have to program. You have to process plan it. Remember, deciding what tools you're going to use, how you're going to hold it. You have to create all the tool path, render what you're holding and what you're cutting. So all of that's there. And this is what we call an edge clamp. Now there's another part called a corner clamp. So here is the corner clamp and you have to do the same thing. Remember, you have to check the model to make sure there's no discrepancies between the model and the print. And if there are discrepancies, you have to make the adjustments. Okay, so this is called a corner clamp left hand. So you have to now make a right hand, but using the resources that you have, which is a model of left hand. So you have to create the mirror image of this model. Okay, so that is the actual project. But there's a storyline to this because you may look at that part and say, hey, that's a nice part. You may say, well, that's not a nice part. I don't know what it is. Okay, so we have a storyline to the PMs because this part is just a component of a bigger picture. So if you wanted to expand your shop and apply what you've built to something that you can use, that is a part that goes into a design that NIMS has created for a supplemental HMI holder assembly. So it actually holds a tablet and it connects to, you can, I think we used it on a Nova Vice, I'm sorry, a Nova Magnet. And you can actually connect it and put it right on the machine and it becomes an Industry 4.0 device. It's something that you can connect to your network at your school or at your company, and you can use it for anything that you need that you might not be able to get out of the controller. And so you have your tablet, you can connect it to this and put it right on a machine and sit and lock it down, and you can use it for whatever you need. So there are several other parts. If you notice, here are the corner clamps in the right view. You can see the corner clamps, and then if you move up top, you can see the edge clamp. And then there are other components that are part of the CAM turning credentials. So we're CAM programming for turning. So we didn't show those actual detailed drawings, but they exist for the CAM turning part. And with a few other smaller accessories, you can build this unit for yourself. It could be a nice, cool project at school. Okay, so that is the storyline of the edge clamp and the corner clamp. So they do have function. Okay, so now we'll get into the data and reports tool, because after you've programmed it, you need to have a way to measure the results of your work and keep track of your students or your employees. What are you actually doing? And are we making progress? Are we teaching the right way? Are we having success with our curriculum? Where are our employees or students throughout this process? So let's pull it up. So this is this application is it's a Google application, and we've written all the scripts and using JavaScripts. So if there's something that you're not allowed to use, we are building a more robust system, but it's a very useful tool. And it has, on this first page sheet, you're seeing list, just instructions, or really just telling you what the sheets are used for. So your list item sheets, scoring sheets, training reports, trainer reports, and org reports. So if we go into our list items, we're showing how we just simply wrote down all the performances. So you see number 1, 2, 3, these are all of your performances. It's not listing performers. They are there, but you're listing performances. So you can see here, Tina was the 4th performance and Tina was the 6th performance, because your goal is to get it 100% correct. So you might not get it right the first time. So you're going to keep working on it until you get it, you are successful. So Tina did it twice. And so all of your students, and you continue to just build down in your database, and you're recording each performance, and then you can measure how their progress, you can measure that against other students, other employees. And then this is just their cohort date. This is just activating them. And here are your trainers. Everything that's done is connected to a trainer who trained you, so we can keep track of them as well. So this is just where we list the trainees. Yes, the performances and the trainers. Now, here is your scoring grid. Okay, this is all pre-populated for you. You don't have to actually do anything. We've already populated it, and these are all the features that we're observing. All right, so we observed the actual feature itself. This is just naming the feature of the part. The criteria, which is in this case is programming and documentation, because you have to program the part and you have to document for instructions. And these are the components. So you can see the first sort is through the corner clamp left hand, and then you can see the corner clamp right hand, and then you have your edge clamp down the bottom, and then your process plan tool list setup sheet. Okay, so scoring is pretty simple. My routine is I normally just, right now it doesn't have anyone in there, but if I were to just put the first person in there, it will come up. But if now when it turns green, I can enter scores. You can see the scores for Paul that came up. If I wanted to put scores in for someone else, this is going to go 0. I can just I'm just looking for what they got wrong, because if I type in any area they got wrong, if I put a 0 here and I put a 0 there. And that's what they got wrong. I can just simply auto score, and it will write down, say they got 10s for everything else, and it keeps the 0s that they have. Scoring is really simple. It's just typing in what they got wrong and then just getting your auto scores, and it will do the rest. So I'm just gonna clear these scores out of here. So very simple. When you are scoring, we're actually connecting trainers. You can see down here, we're connecting the trainers by criteria. So who taught programming, who taught documentation, it could be the same people, but this is what we're doing to connect. And then when we go into our reports, we can track each performance. So we can say performance number 1 is tracked by you, everyone else, and gold. So this is a trainee report. So you represents blue, everyone else is everyone except you, and then the gold. 660 just means there's 66 features because each feature is worth 10 points. And you can see that Paul is slightly below everyone else. Paul's at 610, everyone else is at 616. You have gauges to your right. We can say, okay, how did Paul do on finger thickness? That's where Paul had problems because he didn't get his finger thicknesses. I can look at down here and say, how did he do with edge breaks? He did wonderful with edge breaks, but look at where everyone else is. So now I can see everyone else is doing not so well, but he's doing well with edge breaks. If I go to trainer reports, I can look at specific trainers and it's loading, so just give that a second. And I can look at specific trainers and say, okay, John is a 9.5 trainer and everyone else averages 9.3. A perfect trainer would be 10. It's not usual. I mean, that's very unrealistic to be a 10. That means you're being judged as a trainer. If your students get it wrong, you get it wrong. If your students get it right, you get it right. So we're populating your average based on the people that you trained. It only looks at who you've trained as you keep your score. Now, John represents 32% of all the scores. So you can see he had a good portion of scores, which means he's a pretty good instructor. We can also jump down and say, well, how well did he do with controls, like if he was controlling profile of the surface, and then it will adjust for that. Okay, so he's slightly lower. He's at a 9 for profile of surface, but he still represents 33% of everyone else that trained towards the same thing. And then for the organization, we can look at an organization as a whole. Now we're looking at every trainer and every trainee. So to the left, you have every trainee is averaging around 615. I'm sorry, you as an organization are averaging 615. This middle is statistical data that NIMS can pull in so that your organization can compare itself to other organizations using the same PM. So you're, from the perspective of you, this is your organization in blue and everyone else, which is outside of your community, that are running the same way. Okay, so that's our tool that we used to help you understand what's happening with your performance. So why, do you want to make a project? Do you want to make your own PM? Okay, so let's look at the benefits of customizing your own PMs. Well, one, it provides choices for organizations. So your school has a choice. You don't have to use what we have. What's your infrastructure? What's good for you? It allows trainees to build a portfolio of experiences for employers. Yes, one person can have a CAM credential and another person can have a CAM credential, but also attached to the credential is your actual PM. So now you can show that portfolio to your employers and say, this is the PM I chose for my credential, and look at the complexity level. Now we know everyone has met the minimum requirements because all PMs have to meet the minimum. However, you can choose a much more complicated PM to impress your employer. So it increases employer engagement. Now they can actually get involved in, and if you want them to have access to your benchmarking tool, they can say, wow, I mean, you seem to be really good, and compared to the rest of your class, you're up here. So it's really, and they can engage in helping you. Like you can create, you can have a project where say, hey, I want to work with 2 or 3 companies in my community to create a PM that they all agree on. So now they have engagement into what the students are actually doing, and you have a way of tracking it. relevant to the performance needs of your community. It lines right up with that. Now you can, if you might be in a community that's doing mold work, where there's another community where you're doing aerospace work. You're all being qualified for the same performance, but your expression of it is different because of where you live and your environment. Okay, so the next slide are resources, and I'm going to turn that back over for resources. All right, so I apologize. Anyone want to take that, or I can move through that as well?
I can review those. This is Rebecca again. So basically, we have created an online sample test. You'll be getting a copy of this presentation, and these links are live. It's also all on our website. But there's an online sample test. It's only available when your candidates are logged into our system, but it is for free. And that is going to be available on June 1st. We also have an online preparation guide that will be available on June 1st. If you've seen our other study guides in the past, it will look very similar to that. Autodesk has also made available some training resources. They have curriculum, they have some courseware that you can access. And again, these links will be live when we send this out. And then, we have several other partners. If you go to our website and look at, I think there's a banner on the top that right now is focused on COVID-19, our response to that, but it has a very long list of resources, training resources where we've worked with many of our other partners, and several of them have CAM resources that would relate to this credential. And the one other thing, for those of you on the call that use our credentials, if you have one of our 50 user plans, we are currently offering a deal. If you want to add CAM, it's 50% off. So normally that would be $500 to add it, but now it's only $250. So that's something that we're adding, and that will go through the end of June. So I'll give it back to you, Montez.
All right, so now we can go into a Q&A, and we will use Kendra to read any questions that came through the chat. And between myself and Alex Starner, he's our technical director, we will answer any questions. Hopefully we can answer your questions.
Yeah, okay, so this is Rebecca. I'll start reading off some of the questions that we have. One question is, who can check the part?
Okay, so the part can be checked similar to our system, where if you are an evaluator, if you've gone through our inspector credential, you can evaluate the parts, or we encourage you to take that credential, because as you've noticed, there's a lot of geometrical dimensioning and tolerancing on these prints, and even take one of our workshops if you feel like you need a little bit more support on that. But if you if you earn that credential, you can check the parts yourself. If not, then you would go through your Met Tech to have the parts inspected.
Okay, next question is, let's see. Sorry, there's quite a few questions here. I'm just running through them. They were asking what kind of verification software can be used.
That is very open for your virtual software. We are not vendor specific. We may put a partial on that standard. Obviously, not everyone uses it, but it is something that we encourage that you use for your verification software. But if you decided to use Vericut, that's fine. There's another brand out there that's fine. We just require that you, we partially require and we heavily encourage you to practice using virtual environments where you're testing the G code and not the actual program files from your software using the actual G code.
Okay. Let's see. So someone asked what the testing window is for students. I think I can answer that if I'm understanding the question correctly. This will operate just like any other NIMS credential, where they can complete the performance and take the test in any order. The test, they'll have 90 minutes for the theory test, just like most of our other exams. And Montez, is there a time limit on the programming piece for the performance?
No, no time limit on that. However, you can create a PM of your own and put your own time limit on it.
Okay. All right. Thank you. Some of the other questions I'm seeing are pretty specific. So we will be putting together kind of an FAQ, and some of these specific questions we may respond to individually offline. Another question that we do have is, can these CAM credentials go to any company? I am guessing that's getting to the relevance of the CAM credentials for any company. Montez, do you want to address that?
Any company. So I'll answer it based on my interpretation. So it is the companies, yes, can use the credentials in their organizations, and obviously they can create their own expressions of the duties. Remember, the duties state performance, not specs, part specs. If you look at some of our older standards, you'll see a lot of part specs in it. And what happens there is you're actually, when you start putting in specs, you're creating a box, and that box sometimes is too small for some and too big for others. And so when you define it as performance, they can express it. So the companies, we encourage all companies, and this is actually driven, this whole movement was driven by companies saying that they needed that flexibility because we all do a little bit something different, even though we may align to the same standards. So it's all been driven by companies. So I'll answer that question and say, yes, absolutely.
Okay, thank you. Another question is, will the programmer be required to generate setup and inspection sheets with the model?
No, you don't need to do you need setup sheets, but not the inspection sheet. You create one. Like for example, if you look at our tool, if you're using our tool, every feature has a hard fixed number. So it's feature number 1, 2, 3, 4, 5, and obviously it has the feature name and then all the attributes of the feature. You can create an inspection report that aligns to the data tool, and I would say yes, so that you can cross-reference. This feature is for, you label it number 1, number 2, number 3, so that you can enter your scores in easily. So, but it's not a part of scoring or anything like that. It's just an easier method to enter data into the digital tool.
Okay. Let's see. Is there a specific PM for an instructor to follow to gain their credential? They would just perform the same PM as the students would.
Yes, yes. However, I would say we are working with many organizations to actually develop a portfolio of PMs for the same credential. So right now you're seeing one PM, but shortly you'll see a series of PMs, all associated with the same credential, but they have different expressions of it. And so as a student or a trainer, you can choose which one you want to perform to satisfy our performance.
I think some of these questions that are just coming in, you sort of have just answered in your last answer. So let's see. It says this is a minimum of 2.5 axis. Is that correct?
The part design, if you were designing your own, it would have to have multiple features requiring 2.5 axis. So if you were drilling a hole, you got to use move X and Y to position, Z to come down. That would be considered 2.5 axis, right? So if you were doing, and then you need multiple features requiring simultaneous 2 axis. So you might be cutting a contour where you're doing arc moves on X and Y, and you may even be doing X and Z. And so it doesn't necessarily have to be just X and Y, but at a minimum, you got to do simultaneous 2 axis. But you can also include 3 axis in your design and 4 axis. If you go into 5 axis, we have a standards for that. So that's you can, but it doesn't make sense to earn the CAM programming milling credential. It makes sense if you're going to go 5 and synchronize, because 5 requires synchronized 5 axis as well. So you might as well go up to another role. But yeah, the performance requirements for the standard are minimums. You can take it up as much as you like. Just remember, if you take it up too much, you might go to another credential rather than that.
Okay, thank you. Another question is, do PMs have to be reviewed by NIMS prior to rolling them out?
Yes, absolutely. So we have a vetting process, and so what we assess are is the alignment to the standards. That's one thing. Not the most important. They're all important, but number one, are you aligned to the standards? The project has to demand the performance set in the standards. And then second, we look for quality and errors. And so you may have a great concept, but our staff or our technical staff will work with you to make sure you have the geometric callouts correct, make sure that you're using best practices with your projections on the drawings, and it just makes sure that it's presentable. So those are the 2 things that we look for, and don't feel like you don't have the support. We are here to support you. We encourage you to build your own PMs so that we can have, and we look. Show what you do to the larger community. This is your way to showcase what you're doing at your local community at a national level. And we plan in the future to have awards, most popular, just like a YouTube, going on YouTube and you see the most popular videos. We plan to move this on to even have awards and have competitions for designing. It's going to be really fun.
Okay, thank you. We do have a couple other questions about pricing, which I'll address. CAM can be purchased in 2 ways. You can just purchase, just like like any test, you can purchase just an individual test. And that's $80. So that would be if you wanted to take either the CAM milling test or the CAM turning test. If you wanted to buy a 2-test pass, well, first of all, that would be $80 for just accessing 1 test. If you wanted to buy a 2-test pass and have access to both of them, that's $110. And then, as I mentioned earlier, if you've purchased the 50-student deal for machining and you want to add CAM on, I had the price wrong. It's normally $1,000, but we are running a sale until the end of June. So it'll only be $500 to add that on, and that will add on for all 50 students would have access to it. Those do have an expiration date. It's a 1-year subscription fee. And then once the student activates their account, they have 1 year to use it. Another question about cost is somebody wanting to become a CAM trainer. There's no cost associated with becoming a trainer from a NIMS perspective. We don't We don't charge that. We may in the future roll out a CAM instructor workshop. If you're familiar with our machining workshop or our ITM workshop, that may be something we look at in the future, and there would be a cost associated with that. However, there is not a cost to become a trainer, and we do provide tests for free to instructors. So I'm not seeing a lot. Like I said, there are a few questions that we haven't addressed. We'll address these offline because they're a little more detailed and specific to either technical wise or policy wise. Let's see. There is another question here about the multi-axis. It says, based on what you said about multi-axis, how do entry-level standards align with multi-axis duties? Is there complexity assigned to some duties? Like, I guess this,
Yes. Yes. So we do assign minimum complexity to duties. But it's expressed in performance. So for example, the difference between performance and part specs is performance may specify that you're processing a part or you're creating tool path for 2.5 axes or simultaneous 2, et cetera. So now that's how we're governing the complexity, or we'll say it has to be multiple operations, you must show rendering, et cetera. But we don't say it has to have a pocket, a slot, radius, that is left up to your expression as long as it meets the demand. So yes, we put minimum complexity, and complexity is not just in the duty. Complexity can be in the role as well. For example, we have, just to let everyone know on the call, stay tuned because we're really close, just months or a month away from releasing all of we've overhauled machining standards, and CAM milling and turning programming are just 2 roles out of many roles that we've developed. And so we're bringing out a whole series of roles using this method. And the difference, for example, in a role, if you are a CNC milling operator versus a specialist, an operator for our roles, does unproven, executes proven jobs, where a specialist does unproven work. So that's a difference right there. And then there are also other differences that are included. So just having additional duties associated with the role can govern complexity. And then the duties themselves have complexity written in the performance to also define that.
Okay, thank you. I'm not seeing any new questions come in. Like I said, we've had a few suggestions or comments that we'll address offline. I believe, just make sure. So Montez, is there anything else you would like to add? Or?
No, I want to thank everyone for joining us today. And I know we're under some challenging times with the pandemic. But we're looking forward to seeing all of our customers again as soon as possible when we can get out there. Again, stay tuned for more standards. This is something really big for us, and we look forward to a good future with our customers. Thank you.
All right. Yep. Thank you, Montez. Thank you, everyone. Like we said, there will be a recording of this webinar. It will be sent out to all participants and people who registered and weren't able to attend. It will include this presentation as well as the Performance Measure Development Guide if you're interested in that. And if you have any other questions, please feel free to email us at support@nims-skills.org. And again, thank you, and we hope that you have a good rest of your week.